Okay, I'm sorry for the connection issues. We seem to be broadcasting from Costa Rica or something similar, from one of these South American secluded countries, but no, it just seems that way. So the first thing we have to do here is translation. Okay, we calculate the quadrant acceleration or deceleration. For acceleration, deceleration, we accelerate and decelerate at certain speeds on a two-phase system. So we basically have three positions: the left, the middle, and the right. And we have a movement from left to right, and this is the middle point. So we have to obtain four types of, we have to calculate based on this speed on the left, this speed on the right, and the speed in the middle point. We have to calculate four types of accelerations. So the first type, acceleration type 1, which we called with Excel I1, is the speed, the middle speed from here, minus the speed from the left position, divided by the time. So that's the acceleration. We know from the physics class that acceleration is speed divided by the time, or another way to put it is the distance divided by time divided by another time. So it's basically speed, which is distance divided by time divided by time. So we have basically a pretty simple physics calculation to do here. We have four types of accelerations: from left to middle, from middle to right, then from right to middle, and from middle to left. Acceleration I1, I2, B1, and B2. Okay, they will have they'll be basically four floating points values. The first two will be positive, and the next two, B1 and B2, will be negative, because we have to have a sign, so the blocker will move back and forth, left to right. Okay, so these are the accelerations. So we have the accelerations calculated, and we have our blockers here, which are, as you can see, we have them in the canvas. Let's see if you can see them. Good. So they're right here, each and every one of them. Barrier, barrier, barrier. Good. Let's pick the last one, from the next to last one. We have the barrier and the blocker, and each blocker is has an T01 blocker script attached to it. Let's open it. Let's open this bad boy. Good. So now we will have to basically make these blockers, these yellow blockers, these yellow machines, which you see right here. We have to make them move left and right. I see a problem here. First of all, they are not correctly positioned, because As you can see right here, we have the position set to -7f. Each and every one of them is in -7f, -7f. This one is centered. This one is -3.5f. This one is 5f. Basically, most of them are -7f, and I want to consider that 0f is the center of this this barrier. So something's not going right with the initial position, the initialization of the position of these blockers. So we'll have to see why is that. But for now, we're just gonna let them be as they are, because we want to make them move first. We want to see them move left and right, and then we will solve this other issue. Okay, so we have them here, and we want to make them move. We want to make them move left and right based on these 3 speeds. So we have the left speed almost 0. Then it will change direction and accelerate to the middle point until it will have 2.5 f speed. Then it will have to decelerate again towards the right, then change direction again. Okay, so where do we have this function translate? Okay, let's search this this function translate blocker. Good, so we have it here. Translate blocker. Translate. We have to copy this, paste it here, because you will use it in the update function. Good. Yeah, so we have the acceleration. Oh. The acceleration's calculated right here. We have the acceleration, which we're connecting. Sorry for the interruption, but guess my more cell phone provider doesn't have such good uploading speeds. So we have the accelerations. Okay, we have the deploy counter, which I don't remember what it does. We have the deploy distance. That is the distance that the blocker will move. And we have the deploy distance divided by 2. Good. And let's see what we have here. What do we have here? Deploy counter, deploy distance. Blocker value. So it checks if the blocker is in the first half of its movement. Then, if it's in the second half, okay, it checks if it's right here in the second half of the movement. The mosquito must be probably misgenders me. It thinks I'm Hillary Clinton. And else if deploy counter greater than the deploy distance. So the first if checks if my blocker is right here in the first half of the translation. Then it checks if it's right here, and then it checks if it's outside its movement interval. So if it's in the first half of the movement, and the direction is from left to right, or from right to left, you see it, but I see it as from left to right. Good. Then we add the current speed of the it's basically a position. I think we'll have to see it. It's a misnomer. It's not the current speed, it's practically the position, but doesn't matter because we will explain why it doesn't matter. It's confusing, I know, but just keep up with me. So if the current blocker is moving from left to right, we modify its position. Okay, good. If it's moving from right to left, okay, but we are in the first half, then we add this acceleration, or we subtract the acceleration, the fourth one, responsible for the movement from right to left. Okay, so I quite remember now this code. Else if we're in the second movement, in the second part of the movement, okay, and we're moving from left to right, we use the second acceleration, of course, because now we must decelerate the blocker. One, if we are moving from right to left, but we are here, of course, then we must subtract the acceleration. And yes, it's B2 or B1. There must be something a B1. Let's see. I don't think it's quite right. So I1, I2, B1, middle minus right. Let's see. I2, B2. Incredible. Okay. So let's just watch a little video to see what basically what we're looking at here. Yes. So let me find some video where we have it, where we have them moving here. I want something simple, a simpler level. Level 4. Level 4. This is level 4. Good. This is our level. Exactly the level level 4. Good. So this is where they are. Okay. So they move left and right. You see? Good. Left and right. This one is faster. Good. This one is a rotational blocker. Rotates only. Left and right. You see? Good. So left and right. This is what this function does. This method. So can we change the speed right here? Normal 0.25. Okay, good. So okay, this one is a rotational one. Okay, this one moves left and right. Okay, left and right, left and right, left and right. Okay, so if the blocker is in this position, the left position, or if the blocker in this is in this position, the right position, well, we check this fact right here. If it's in the left position of its movement, this is the if that checks that. We must check if the movement is from left to right or from right to left, and depending on that we modify its position. In this else if we check if it's in the right position, and depending on if the movement is from left to right, we modify its position. Okay, and if we exceeded our movement or translation, we must change our direction. So we must see here, we multiply it by -1, and now if our current direction is positive, that means we have changed our movement position from right to left to a movement position from left to right, and vice versa. So we must reset position with distance lost. You must see what this does. I don't remember why I had this method here. So if they move, these blockers move perfectly. That means they didn't quite move perfectly, and this translation modified its the blocker position, center of movement in time. So we set it. I had to reset it each time the blocker returned to its initial position. I had to reset it. Reset blocker with distance last. Reset blocker with distance first. So distance last. Okay, we have to see what this did. Deploy counter 0F boon. Okay, so deploy counter is practically a counter that counts its current position. Good. I remember. And this boolean value, I don't know what it did. It's true. I don't know what it did. If advanced blocker with distance forward, so I know what this boolean variable does. So this translate blocker function, translate, we have to comment right, translate the still blocker, translate the blocker. Okay, let's see what advanced blocker with distance does. Advanced blocker, let's touch it. Advanced blocker with distance forward. Deploy. Blocker. Advanced blocker. We have to use the right hand for thinking. But then I have to use my left hand on the mouse, so I have to use my left hand for thinking and use my right hand for the mouse. So, good. So we have it here and here. So where do we have to put this function? We have to put it inside our blocker. Our blocker. Good. Let's paste this also. Advanced blocker with no. So basically we're increasing the counter that measures the distance of the blocker from the initial position to the acceleration. Blocker geo left right transform position and pause. Good. Start line and end line are the vectors that we will be using for the meshes, for the mesh that will be the expansion of the blocker. You see, so immediately after you hit a blocker, it will start expanding. You see, right here. So it starts expanding, and this is the point, the center point. See, it has a center. It's basically their pivot point, their rotation point. This we have here. We have two vectors, basically a vector, two vectors, and let me expand the blocker. Good. This is the start vector, and this is the end vector. Basically starts expanding, and the start line, the start vector will move its position in the lower left corner. The end vector will move its position in the upper right corner. So this is the meaning of start line and end line. Good. And initially, before we shoot them, they will have to move position based on this acceleration, and they will have the same movement as the blockers. Good. So this is what this function does. Let me think where we will put this function. So if this is the translation method that basically moves the blocker, and it resets its direction, it's good. So we'll have to put it here now. Here, I have to put it here. Yes, I have to put it here. So we add another function here. Good. So let's see, what do we miss? What do we miss? We miss more. we have to get this by here and move them right here. Good. One. Moved from T0 electron 1, 2 to here. One. Okay. Now we must get rid of the errors first. Let's see how much errors we will have. Probably plenty. Ten tips for hardening your Linux servers. Does electricity travel at the speed of light? No. When you meet a Greek on Omega. Programmers in movies. Okay. Good. Compiling C# scripts. Doesn't seem to be a problem, no? Good. Huh? No problem? That's good. We have no problem. Hold on. Good. Errors. How much? How much errors? How many? How many? How many? Good. Plenty. 70. Good. Let's see them. So we have 70 errors. Deploy this does not exist in the current context. Well. Bun. We have translate blocker here, so we must comment this out. We don't need it here. We don't need it here. Să ce comentat, înțeleg. Așa. Okay. Good. Bun. Let's see if errors disappear. How many? How many? $50. Good. Deploy distance 1, 2, 2, 1. The 1000. Bun. We comment this out also. I don't remember why I have two types of functions. It's a mess in this code. It's a mess. It's pretty messy. Trial and error. This is what you have to do when you have to port Java to C#, and there's lots of code. You don't want to start from zero. Okay. 8 errors. Good. And it's good we have them now in okay, Boolean. We need this to be true. Boolean. What do we need here? Hold on. Previous. Okay. Previous. Oh, forward. Good. Returner. Come on. I'm gonna comment this. Okay. Okay. Reset blocker position with distance first. No. The name math does not exist in the current context. Okay. So we have to import what? 318. What? You don't have these? Manabs. Unity engine, click on this Unity engine. No, not this. Some globalization. Probably this. Let's see. Yeah. Good. Math. Okay. No, what's that? Not this. Stem link. Maybe this. Nope. So it's not math. It's not math. System. Of course. Good. Of course it's system. That's not gonna the definition for apps. Whoa. Good. Absolute C#. So it's just type error. So it's capital A. Good. Reset blocker position with distance last. Reset blocker position with distance first. We gotta search these two methods, and we have them right here. No, yes, no, yes, no. Okay. There is no argument given that it corresponds to the required formal parameter Excel. Okay. So let's find these two functions first. So we have. Let's paste them from here. Picture of the game. It will look a little bit messy, but that's no problem because nothing is perfect in life. Nothing's perfect in life, and one of the most non-perfect things in life uh, is source code, ported source code from other programming languages from Java to C Sharp, from C Sharp to Java, from Python to C to Rust and to uh, Ruby. Good. So this is the method. I'm gonna paste it here. This is one, and this is the second one. Oh. Okay. This is the second. Okay. Set position just as last born. Okay. Let's see what this does. Blocker set position. Deploy distance. Okay. This is basically the JavaScript code, no, the Java code. Excuse me. There's no JavaScript in this game. Let's see the compilation errors again. Pretty awesome. Oh, okay. Circle. Circle vision. We don't need these. Okay. We don't need this. We don't need these. Just need these. Okay. These are basically I don't know of the state of libGDX today, but 7 years ago libGDX didn't have collision detection. So if you had a sprite with an object, spaceship for example, you had to create your own collision detection system. So mine were basically circles. I had to keep track of this also. Of course, with Unity now, um, with where is the spaceship? With rigid body, they're automatically done. You have the collision detection system right here. You can modify it from the integrated development environment directly. You don't have to write any code. So it's pretty simple. But let's return to the code right here. So we have the position. Okay. Let's arrange the code a little bit to be a little bit more readable. Okay. All right. Oh, but we don't have any right. Start line. Okay. Pretty. I don't think it's gonna work because because okay. Good. Advanced blocker with distance backward. Oh, it's the advanced. We need this function also. Okay. Where is it? Set advanced. Here it is. Blocker with distance forward. We have blocker and current speed. Blocker and current. Okay. Blocker. Mesh. We don't need this mesh. Current speed. We don't need the mesh. We don't need the mesh. Okay. We don't need the mesh. Okay. Forward advance backward. Okay. Paste this here. As good. We have this, and then this. We have broken. So. Let's see what Unity says. Good. Blocker does not exist in the current test motions. Blocker deploy camper. Good. So we have a blocker here. It's a big mess right here. It's a big mess. It's a big messy mess. Boom. Advanced distance the blocker. What do we have here? Blocker. What is this blocker? This blocker is practically blocker player mesh. Can I have that mission here? Good. Let's see what we can modify here. So we basically don't need all this mishmash, complicate stuff beyond what we need to complicate. So we don't need this. We don't need this. We don't need this. And we don't need this. We basically have our blocker here. So this is good. Okay. This is good. Okay, this is good, and this is good. We don't need we don't need it. We don't need this. We don't need this. It's basically good. Reset position or distance. Basta. We don't need this. We don't need this. We don't need no arguments there because this is Unity. We do things differently here, and we don't need this, and we don't need this. We just need this, maybe. Okay, but we don't need this, and we don't need this. Okay, good. So we don't need that. We don't need all. Just a little bit. Oh. Good. And advanced Excel. Good. It's good. This is good. And this is good. Oh. We have a little problem here. Might as well game object. Let's keep it right there. Okay. Well, so let's check Mr. Unity right here. Compiling C# scripts. Good. From 18 to 31. Good. Okay. The name block attention. Good. It makes sense. Next one. 367. 367. Ah, good. That's not a way to change position. That's not a way to change position. Put block library distance. This will be okay. Alright, okay. We basically need to reset position of blocker. Is this okay? In the right. And we basically need to change reset positions position of blocker in the right. We shall need to good. Okay. So I think it's quite enough for today. We have a lot of work to do. It's a lot of code and a lot of Java to C# translation, and libGDX to Unity translation of concepts, of game objects, of sprites, of basically a totally different game development environment. So we will continue following days, following weeks, following months, until we redesign this game. Make it a little more playable. Okay. So we'll basically make something like this, but with much easier controls. We have too many buttons here. We'll just have to touch the screen to move the spaceship left and right, forward, and to shoot the space blockers. I'm thinking about a new. We will shoot at them not by pressing the lower centered button here, but we will just tap them. You tap the the blockers and the spaceship will directly shoot at them. We will just have to pick the right time to tap them, because if they're not at an angle lesser than 40 degrees, they will not block the barrier, as you can see right here. The angle must be less than a particular value, and the maximum value is 40 degrees. Okay. Okay, well, this is it. A simple game apparently, but not so simple, because these blockers have very complex movements. We'll have to use a little bit of trigonometry, simple physics, simple algebra. As far as math is concerned, the most advanced math you will use here is trigonometry, so it's not very complex. It's basic tangents, arctangents, tangents, not tangents, basic vectors, so it's not going to be very complicated. Uh, okay. So we will see how this goes. Basically, we have all the art, all the sprites, the graphics. It's all already rendered. We have the graphics for it, for the game. We just need to code it now. It will take probably a few months. Too little time. 2, 3, 4, 5, 4 months to have a playable demo. And a working game, complete game. Okay, between 4 months and 10, 12. It will be a long project. Okay, so we'll continue the next months, weeks, and we will play with Unity. And in the future, who knows, maybe Unreal. The most powerful real-time 3D creation tool, Unreal Engine. The world's most open and advanced real-time 3D creation tool. Huh? Yeah. Yep. Omno. Forgotten. Okay. Hit the next level with the most trusted engine in the world. Full control, gorgeous graphics and tools made for every game. It's your title, your way. Very beautiful, very nice. Games, film and TV, architecture, automotive and transportation, broadcast and live events, simulation. More uses. Simulation. Yep. Okay. Until next time.